Very good morning, students. Welcome to IIT JEE NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome class 7 students of Masterminds Falaknama so far for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Today we are going to start a new chapter, chapter number 5, electric current and its effect. So today we are in session number 1. So probably the next week we'll get 2 more classes, total 3 classes to attend for the test 5, which is on 25th of November, right? So be focused to the topic. So very important topic, which already you learned in the class 6th about the basics of electric current and electricity. The same, we'll review them and going for the new concept, that is, what are the effects of electric current we learn in this session, right? Okay. So first of all, before going for the directly to the topic, let me explain about the prehistory of the electricity, right? Prehistory. So the electricity, the word is derived 2600 years back, years ago. The word electricity is introduced 2600 years ago by a Greek philosopher, Thales, right? A Greek philosopher named Thales. So this is observed when the two different bodies are rubbed with each other. First, what they have done is, there is one umber with fur. Umber is a stone, a sky blue color stone. When rubbed with the animal hair, when the two bodies are rubbed, what he observed is both of them are repelling with each other. Means when the two bodies are rubbed, they are getting the charges, opposite charges, right? So you know there are 2 types of charges are there, either mathematics or sciences, positive and negative charges. So that is the first observation made through rubbing, which is called friction. When the two bodies are rubbed with each other, due to friction, both the bodies are getting opposite charges. Means we are giving charge to the body. That is called electrification, which we learned in the earlier class. So from that electrification, the total electricity is developed. So whenever electricity comes, suppose you have TV, you have computer, you have AC, geyser, mobile phone. How all these are working? Just because of the electricity. So there are a lot of iron boxes there, right? All these are working with electricity only. So we cannot imagine even fraction of seconds without electricity. So welcome in the Resham branch, right? So electricity plays very important role, or has a lot of applications in our day-to-day life. So there are so many sources, although so many ways you can get electricity, not only by one way. There are so many sources where you can get from electricity, right? So what is source? First one is cell, a small source. It is around 1.5 volt, right? A small source of electricity is cell. You know cell, na? You use in the remote controls. Okay. Then we have the little better one, battery, which is around 3 volts or 6 volts, 9 volts batteries are in the market, right? They are batteries. And further, there are so many types of batteries, are different types of batteries, which you already seen in the lower class. Here also will refer. Different types of batteries like Leclanche's batteries, dry cells. So many are. For example, when you see in the car, 2-wheelers will use the battery for self-start, right? All these are the source of electricity. Apart from this, we can produce electricity from water, hydroelectricity. We can produce electricity from coal. We can produce electricity from heat. We can produce electricity from even garbage. Or you can produce electricity from wind. There are so many companies are working in producing electricity by so much sources. Even garbage, what garbage you are throwing outside, that also taken and they are compressed to get the electricity. So there is a lot of even solar, the most important one. Electricity from sun, solar energy. Solar from sunlight can be converted. Let's see, nowadays they are using solar panels. So there are a lot of sources are there for electricity, and of course, lot of requirement also there. Okay, lot of requirement is there. So apart from this, there are some more are there like generators, inverters, right? Even transformers which supply by the electricity department. All these are the sources of electricity, right? So electricity is derived by the word derived from the Greek letter by Thales. Then he given statement that there are two types of charges, positive and negative charge, electric charges. Then there are a lot of sources are there for electricity. It may be in the form of small sources or larger large sources or larger sources, cells, batteries, different types of batteries, and the electricity produced from water is called hydroelectricity, produced from coal, thermal, produced from heat, produced from garbage, produced from wind, produced from sun, right? So many sources are there to produce the electricity. Okay, and requirement also like that only. There are a lot of requirement is there for electricity because we are running so many devices with the help of the electricity, even including cars and vehicles. Nowadays there are electric cars, electric vehicles. We are running them by using the electric current. Means we are increasing our requirements as well as source to generate electricity. That means electricity is having the wonderful applications in our day-to-day life. Believe it at all, right? Right. Okay. Now, just basics. We'll see synopsis 1. So there are 3 synopses we can discuss in this chapter for the exam. Electric charge and charger bodies. Simple one. Electric cells and electric circuit. Next topic. Electric current and its effect. Right? These are 3 topics, 3 synopses we are going to discuss in the 3 days so that we can appear for the test 5 on 25th November. Okay. So when you come for the first synopsis, electric charge and charged bodies. So what is electric charge? Generally, every substance contains atoms. Each atom contains equal number of positive and negative charges. So atoms are neutral, no doubt. That is called neutral. So correct. So every substance is made up of atom containing equal number of positive and negative charges. If the body is containing more number of positive charges, called positive charged body. If it contains more number of negative charges, negative charges. Otherwise, it is neutral only. Clear? So generally, atom is electrically neutral as per the statement. Electrically neutral. So whenever suppose 2 atoms we have, it contains 3 positive, it contains 3 negative, or negative 3 positive. But when these 2 are rubbed, what happens? There is a transfer of electron takes place. A body, the electrons number increases. In this body, positive charge increases. So body which contains more number of positive charge will be the positively charged body. A body which contains more number of negative charge is a negatively charged body. Then there are 2 types of charges present. Right? Right? Then electric current. Yes, that is our topic name. So generally, what is current? The flow of charge. When charge flows, the flow of charge. When charge flows, charge either may be electrons or maybe protons, or positive charge or negative charge. When it flows from one place to another place, For example, when you switch on the current, we are switching on the plug, the fan is rotating. Or when you switch on the switch, light is glowing. Means whenever you are pressing the switch, charge flows through the cable and makes the bulb to glow, makes the fan to move, makes the AC to cool, makes the refrigerator to work, makes the geyser to make the hot water. All these things because of the flow of charge. Such flow of charge, that too, we can use the word rate of flow. How fast it is flowing. The rate of flow of charge is called electric current. So mathematically, I is equal to Q by T, the formula for electric current. I is equal to Q by T. Q is called charge. I is current. Q is charge. T is time. So we are saying rate. Now rate is nothing but speed. How much speed? So what is charge? Charge is measured in, already learned lower class, coulomb. And time is measured in second. So coulomb by second is the unit for current, or it also known as ampere. What? Ampere. Ampere is the unit for the electric current. Okay. Ampere is unit for electric current. Right? So electric current is nothing but the rate of flow of charge or flow of charge per unit time. How much fast charge is flowing? How much fast charge is flowing? If the charge flows more current, more amperes of current, more coulomb per second of current. That is mathematically given by the first mathematical formula in electricity. I is equal to Q by T. So Q is called charge, T is called time. Charge is measured in coulomb and time is measured in second. Coulomb by second, our standard unit is, after name of the scientist, ampere. You divide the formula, given the formula. Okay. Clear? That is about electric current. Electric charge, electric current. These electrons move always from lower potential to higher potential. What is potential? Capacity. For example, you see, if you take water, it flows from high level to low level. High level, which tank to tap. High level to low level. Correct or not? High level to low level. This tank, it comes to water, tap. They won't go from tap to tank. That is water. Similarly, heat. Heat flows from hot body to cold body. Correct or not? Heat always flows from hot to cold end. Right? Clear? That is convention. Similarly, current also flows from higher potential to lower potential. That is positive to negative. Higher potential, where there is a higher capacity is there. Where there is a capacity of current is more. That is called positive. Positive to negative. The direction of electric current is always from positive to negative. Okay. So this is about the three important points about the electric current. Electric charge. There are two types of charges, positive and negative identified. A body which contains atom or a body contains more number of positive charges is a positive charged body. A body which contains more number of negative charges are called negatively charged body. Right? Negatively charged body. Then the rate of flow of charge or flow of charge per unit time is called electric current, which is measured in coulomb by second or ampere. Okay. It always correct. Electric current always flows from higher potential to lower potential as per the convention. Even see wind also flows from high pressure to low pressure. Wind, water, high level to low level, heat, hot body to cold body. All these are called conventions only. So as per that, current also flows from higher potential to lower potential. Okay. Then another important term will come across is when you have taken so many bodies, you have with you one iron, one gold, one silver, one rubber, one plastic. Right? All these are there. You are passing current. But all the substances does not allow the current. Suppose, why you wear the slippers while you are touching the electricity? because slippers or rubber does not allow the electricity. But our body is a good conductor. Means the substances which conduct electricity or which allows the electricity to pass through them are called conductors. Whereas the substances which does not allow the electricity to pass through them are called insulators or non-conductors, right? Conductors and insulators. So, see clearly mentioned here, the substances which allows electricity to pass through them are called conductors, metals, human body, graphite, coal, etc. Earth also a good conductor of electricity. Earth is a big conductor. It can take any amount of current into it, or it can give any amount of current also. Okay, because it's a big magnet. So, based on the conductivity, electrical substances are classified into conductors and insulators. Of course, one more is there that will come across in next semiconductor. So, the substances which allows the electricity to pass through them are called conductors. So, metals, human body, graphite, coal, all comes under the metals only. The next one is insulators, or they are also called dielectrics. The substances which does not allow electricity to pass through them, like plastic, diamond, wax, wood, all these are comes under insulators because it does not have free electrons. As there is no free electron, there is no flow in the insulators. Okay. Then third category is semiconductors. Semiconductors means they partially allows electricity. They partly allows electricity. The substances which is neither completely conduct electricity, neither completely stop electricity. For example, silicon, germanium. Generally in periodic table will come across. The fourth group elements all comes under semiconductor because study of semiconductors is a very important branch in physics, that is electronics. Electronics means our electronics, TVs, computers, everything contains semiconductors only. Okay, that is all the substances on the behavior of electricity, they are classified into conductors, semiconductors and insulators. Right? Understood? It's already you learned in the earlier class 9th. Right? Then again, same topic which you already learned in 6th class, electrification. So when you are giving charge, suppose already I told, all the bodies are electrically neutral. Right? Electrically neutral means they contains equal amount of positive and negative charges. So that is a statement is given. Atom is electrically neutral. Correct or not? What is meant by neutral? Same positive and negative charge if it contains called neutral. Equal number of positive and equal number of negative charges. Equal number of electrons and equal number of protons. But whenever either it loses the electron or gains the electron, what happens? Either electrons number increases or proton number increases, or negative charge increases or positive. Then they are become like a charged body. Then how they are getting the charges? So like that we are giving charge to atom. The phenomena of giving charge to atom is called electrification. The process in which charges in a body can alert and body can be electrified. We can charge substance by using so many methods. So how we are giving the charge? In earlier, they used give the charge by rubbing. While rubbing, both the bodies are getting charged. That is called charging by friction. Like that, there are so many methods are there to give the charge. When the two bodies are rubbed, when the body attains the charge, that is called charging by friction. Either umber, fur, glass rod, silk cloth, ebonite rod, cat skin. Any two bodies rub, comb and hair. Any two bodies when you rub, they both will get the charge. Such method is called electrification, and that specification is charging by friction. So the first method of electrification is charging by friction. Next, charging by conduction. When the two bodies, one is charged body, other is uncharged body. when they are in contact, right? Suppose you have taken one positive charged body. You have taken one uncharged body, neutral body. When you kept side by side, so uncharged body will get the positive charge, same charge. That method of giving charge by contacting with the two bodies is called conduction, because the charge is transferred. All the charge transferred to the air particles and it moves to the body also. So total surroundings become the positively charged, same charge. That is called charging by conduction. So third method is charging by induction. Induction means without direct contact. Suppose you place the negative charge body here, one body here, neutral body. So around of this air particles are there. So what happens? This negative charge moves to air particles and moves to the slowly to other body also without direct touch. Either with direct touch, without direct touch, or by rubbing. All the three methods are to electrification or to give the charge for a body. So electrification is nothing but the method of giving charge for a neutral body. It may be either by charging by friction, charging by conduction, charging by induction, and fourth one, which is the nature's phenomena. It takes place in nature, that is lightning process. You can see lightning in the rainy days. Why lightning will come? Because of the electrification between two clouds or cloud and the particles, rain particles, dust particles, earth. So because of colliding with each other, they are producing we are getting the, right? That's a very important process where you can find lightning, then followed by thunder. Thunder is a different thing, but lightning also one of the nature's process to produce or giving a charge for the bodies. What happened here when the two clouds are colliding, the charges is transferred from one cloud to another cloud, or cloud to the surrounding particles, or cloud to the earth. Due to that, we get the light, which is need to protect. If the lightning is more, this damages so many things. So these are the four important methods or very important process to produce the charge, which is first observed by Thales, right? So first you have seen what is electric charge, what is electric current, what are the conductors, what are the insulators, what are the semiconductors, what is electrification, and what are the methods of electrification. Four methods. One is by charging by friction, charging by conduction, charging by induction, and finally charging by lightning in nature. Clear? So before going for the further, let me show you one video on the basics of the electricity, right? Just watch the video, then we move to the next part of the chapter. A lot of information is there in this. So carefully, all the chapter is covered here.
Electric circuit. The closed conducting path in which the electric current flows is called an electric circuit. An electric circuit constitutes of a source of electric current, cells, etc., a conducting wire, an electrical appliance, bulbs, etc., a switch or key. When the switch is closed, the circuit is said to be closed circuit. In this condition, current flows and appliance works. Example, the bulb glows. However, the circuit is said to be open circuit when switch is open and there is no flow of current. Source of electric current. A device that produces an electric current is called a source of electric current. Example, cells, batteries, etc. Battery. When two or more cells are used to draw an electric current, the combination of cells is called battery. In battery, positive terminal of one cell is connected to the negative terminal of the next cell. Many devices such as torches, transistors, toys, TV remote controls use batteries. Bulb. It produces light and is represented by coiled wire inside the circle as shown. Connecting wire. The connecting wire is represented by a straight line. It is usually made of copper and provided with insulation. Plug key. A plug key is an electric switch. It is shown in both on and off positions in figure. Cell. A thin long line represent the plus terminal and thick short line the negative terminal as shown. Battery. A combination of two or more cells is called battery. Its symbol is also a combination of cells symbol as shown.
These are the sources.
Fuse. It is safety device in electric circuits. The components such as cells, bulbs, wires, etc. are called elements of an electrical circuit. The various components of the circuit are represented by standard circuit symbols. It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram as shown. Symbols of some common components are shown. Heating effect of current. When an electric bulb glows continuously for a long time, it becomes very hot as some part of the electrical energy is converted into heat energy. This is known as heating effect of current. The heating element in many electrical appliances like electric rod, electric oven, electric toaster, etc. is made of nichrome alloy. Take a 10 cm long piece of nichrome wire. Tie it between the nails. Now, touch the wire and switch on the current in the circuit by moving the switch to on position. Touch the wire again. Do not hold the wire for a long time and switch off the current. Touch the wire again. After a few minutes, we will observe that the wire becomes hot when an electric current passes through it. This is the heating effect of the electric current. Safety devices. Mini circuit breaker used to protect circuit from strong current. Strong current often leads to overheating of wires, which can result in the breakout of fire. Fuse also used for protection of circuit, which consists of a thin wire of low melting point. In 1820, the Danish physicist Hans Christian Ørsted discovered that flowing current in a conductor generates a magnetic field. Ørsted demonstrated this by connecting the two ends of wire to a cell through a switch. Then he placed magnetic compass near the wire. Now when he allowed the current to pass through the wire by closing the switch, he observed deflection in magnetic needle. He also noticed that it requires its original position when the flow of current is stopped. Take a discarded matchbox and wind an electric wire a few times around the cardboard. Place a small compass needle inside it and connect the free ends of the wire to an electric cell through a switch. Note the direction of the compass needle. Bring a bar magnet near the compass needle. We will observe that the needle gets deflected. At the same time, move the switch to the on position. We will again observe that the needle gets deflected again. Now move the switch back to the off position. We will observe that the needle comes back to its original position. So, we conclude that when electric current passes through a wire, it behaves like a magnet. Take the tray from inside a discarded matchbox. Wrap an electric wire a few times around the tray. Place a small compass needle inside it. Now, connect one free end of the wire to the terminal of a battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Insert free end of wires into half cut of potato and observe. You will observe that a compass needle gets deflected and also find that it was always the wire connected to the positive terminal which has greenish blue spot around it. They felt that the discovery was very useful because it could be used for identifying the positive terminal of a cell or a battery concealed in a box. Electromagnets. Current-carrying wire or a coil of wire behaves like a magnet. If a permanent magnet is brought near the coil, one end of the coil gets attracted and the other end gets repelled. This shows the opposite polarity of the coil. If a piece of soft iron is kept inside this current-carrying coil, the iron piece gets magnetized temporarily. Such magnets are called electromagnets.
Electric bell. An electric bell is one of the most commonly used applications of electromagnets. It works on the magnetic effect of current. It produces a repetitive buzzing or ringing sound when an electric current is passed through it. Electric bells have been widely used in telephones, fire, and burglar alarms, at railroad crossings, as doorbells, school bells, and alarms in industrial plants, but they're now being replaced with electronic sounders. An electronic bell consists of an electromagnet, springy iron strip, a hammer, a gong, and a switch. An electric bell works on the principle of electromagnetism. It is a simple device which has a U-shaped solenoid, one end of which is connected to a spring of the switch, and the other end is connected to a soft iron armature. Basically, all the components such as the switch, electromagnet, hammer, soft iron armature, and spring are connected in a circuit to make an electric bell. When electric current is allowed to pass through the circuit, the iron core of the solenoid gets magnetized and pulls the soft iron armature, which causes the iron hammer to strike the gong. When the armature moves toward the poles of the solenoid, the circuit breaks and the solenoid loses its magnetism. This forces the armature and the hammer to return back to their original position.
Right. So we have seen the complete picture, total picture about this chapter. Not only electric current, we learn about what are the effects of electricity, which we are going to learn in the next classes. Very interesting video that is, you can see repeatedly, so that you can understand more about the electric current and its effects. Okay. Now you can see next. When you move to the next one, right, continuation, the source of electric current. Already I told you from where we are getting the electric current. There are so many ways where we can get the electric current. That is called sources. Sources means from where we'll get it. So there are so many are there. Number one, for example, cell, I told already. Number two, batteries. There are so many types of batteries are there as per our requirement. Not only used in the torch light and all, also there are batteries used for two-wheelers, four-wheelers, or train, or it may be industries, cars. They are also comes under batteries only. So many varieties are there, right? So they also comes under the sources only. And even electricity can come from the solar energy, already I told, from water, from wind. We can produce electricity from heat, from coal, from garbage. So there are so many ways to produce the electricity as per our requirement, which is called as sources of electricity. The same thing given here. So what is electric cell, which is the smallest source of electricity? Compared to any source, the smallest one is cell. Only 1.5 volt. If you see a cell used in the remote controls and your toys, it's only 1.5 volt. So like that, there are so many are there. There are so many sources which can give electricity and which is called electromotive force. The energy supplied by a source is called EMF, electromotive force. So electromotive force of cell is 1.5. Electromotive force of batteries is 3 volt or 6 volt, 9 volt, 12 volts. Suppose if you go to your residential, for our house purpose, we required 220 volt supplied from the transformer. That is also electromotive force. Energy supplied by a source. Energy supplied by a source to drive a charge. to drive a charge, right? Is called electromotive force, which is also one of the important sources in the. There are so many cells are there. We learn in our class: voltaic cells, Leclanché cells, dry cells, liquid cells. In all these cells, what happens is chemical energy is converting into electrical energy. There are so many types of chemicals will be there. Maybe dry chemical or liquid chemicals or a paste-like chemical. These chemical energies are converted into electrical to give the electrical energy for us. Similarly, water energy is converted into electricity. Wind energy is converted into electricity. Solar energy is converted into electricity. All these are the same methods where we can find the conversion of electricity into conversion of various energies into electricity, which are called sources of electricity. Okay, there are so many are there. See here, voltaic cell. So one kind of cell which can produce electricity from the. We can see the bulb is growing through the chemicals by the process called electrolysis, right? So which is invented by the Volta. The name of the scientist only Volta, Italian scientist Volta. That is called voltaic cell, where we are producing the electricity from chemical by the process called electrolysis, where there is a transfer of charges takes place from one coil to another coil and gives out the electrical energy. Zinc sulfide is used here, right? The positive ion of zinc and sulfate negative, they combine to give zinc sulfate and produces the electricity for us. And that zinc sulfide is converted into electricity. That is chemical to electrical. Is the one kind of cell. Now, when you move forward again, there is a different types of cells are there, like there are disadvantages of the different cell, advantage and disadvantage. Then we have the bichromatic cell. Bichromatic cell, another type of cell where you can find you can produce electricity from chemicals. So any cell you take or any battery, they all produce electricity from chemical energy. Chemical energy is converted into electrical. Okay. Now that is voltaic cell, bichromatic cell. Everyone is having its own advantage and disadvantages. Next, Leclanché cell, one kind of cell. Where Leclanché, dry cell. We'll use at home for remote controls and dry cell. So how dry cell is constructed? So you can see one rod will be there in middle, dry cell. Graphite rod. Okay, that is dry cell. All these cells, which are the sources of electricity, or converts the chemical energy into electrical and gives out electricity for us. Okay, wherever you want remote controls or wherever you want in the radios, everywhere you can find the presence of this. Okay, so we'll continue the same in the next class. We'll continue what we learned so far in the next classes about the cells and all. Then we'll go for the effects of electric current further. So that's all for today. You can see on the screen the home task, homework. Define electric current, mention its units. What is electric current? The rate of flow of charge or flow of charge per unit time. I is equal to Q by T. It's called electric current. Okay, Q by T. So units are coulomb per second or simply ampere. Ampere is the unit of current, right? The standard unit. Okay, so that's all for today. So thank you very much, students. We'll meet you again in the next class with more information about the effects of current. Thank you.